Here we're looking at section 10.6, and we only have one learning target today. And our learning target today is use segments of chords, tangents, and secants. And remember, we looked at chords, tangents, and secants before. Now we're just using segments of them. So here's our first theorem. So segments of chords theorem. So if two chords intersect inside a circle, then the product of the lengths of the segments of one is equal to the product of the lengths of the segments of the other. So if I look at these two chords here, I know that EA times EB, so those two pieces multiplied together, equals EC times ED, the two pieces of the other chord multiplied together. Okay, so here we're going to be multiplying pieces of our segments of our chords. So here I'm asked to find ML and JK. So I'm given some values, and I'm going to use that previous theorem. So I know that I'm going to have NK, which is X, times the NJ, which is the longer one, equals MN times NL. Okay, so then I substitute what I know. So I've got X times X plus 4 equals X plus 1 times X plus 2. So then I can go ahead and multiply those out and simplify. Then I want to subtract this X squared from each side. Then I'm going to subtract 3x from both sides, so I end up with x equals 2. But this was not necessarily my final answer. I was asked to find ML and JK. So now that I know what x is, I can substitute that in. So ML was x plus 2 plus x plus 1, that entire length. So I substitute in at 2 for anywhere I had x, and I solve. And then I can do the same thing for JK, which was that other chord. So I know I have x plus 4, and I substitute that in. So I know that ML was 7 and JK was 8. So now here I want you to try this one. Looks exactly like the ones we just did. So now here's our big core concept. So a tangent segment is a segment that is tangent to a circle at an endpoint, right? So here's a tangent segment. It goes to that point and to the point where it's tangent to the circle. So a secant segment that can is a segment, right? So my secant goes through the circle, has two pieces to it. It has an external segment, so the part that's outside the circle, and the secant segment, which and the internal, which is inside, right? So I'm dealing with two different pieces of this secant segment. Okay, so let's look at some examples of this. So here's my segments of secant's theorem. So if two secant segments that share the same endpoint, so here they share point E, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So here it's a little bit different. I'm not just going to multiply the pieces together. So here I take this external piece and I multiply it by the whole thing, right? That's this whole thing right here. And then that's going to be equal to this external piece times the whole thing. Okay, so here I'm not just looking at the pieces, I'm multiplying the external part by the whole thing to set them equal to each other. Okay, so now here I'm asked to find the value of x. So first I see that these two secants do share that endpoint that's outside the circle, so I can go ahead and use that theorem. So I know I'm going to have the outside times the whole thing equals the outside times the whole thing. Okay, so then I can substitute what I know. So here was the outside. The whole thing, I could add them together to get 20, equals the outside. The whole thing I add to get x plus 10, because that's the entire length of this secant right here. So then I can just substitute and simplify. Then I subtract 100 to both sides because I want to get this x by itself, and then I divide by 10. So x, which is what I was asked to find, is equal to 8. So now here are a few I want you to try. Remember here that it's the outside piece times the whole thing equals the outside piece times the whole thing. So here's our next theorem. Okay, so here I have a secant and a tangent segment. So if a secant segment and a tangent segment share this endpoint, then the product of the lengths of the secant segment and its external segment, so kind of what we did in the last one, so the outside times the whole thing, equals this tangent segment squared. Okay, so now let's look at an example of that. So find RS. So here I see I have a secant and a tangent that share this endpoint. So I know for the secant I have to do the outside times the whole thing. For the tangent I have to multiply this by itself, so I have to square that value. So now I can just go ahead and substitute the things that I know. So the tangent segment was 16, so I'm going to have 16 squared equals the outside piece times the whole thing, which when I add these together, it's x plus 8. So then I can simplify, so I end up with 256 equals x squared plus 8x. So I write this in standard form, and by standard form I mean I get everything over to one side of the equation. So when we have an x squared term and an x term, I'm going to want to use the quadratic formula to solve this. So here's a reminder of the quadratic formula if you don't remember it. So we take a negative b plus or minus the square root of b squared minus 4ac and divide that whole thing by 2a. So when I have this in standard form, I have my x squared term, then my x term, and then my constant. So the number that is with my x squared term here, so in this case 1, is my a value. All right, so here's all the places that I plug in my a. So the term, the number, the value that is with this x becomes my b value. So anywhere I see a b, I plug this in. And be careful here that we make sure we have negative signs where we need to. And then this number back here, this constant, is my c value. Okay, so I can plug those values in, and I always have to have a plus or minus, right? So I'm going to have two possible solutions here. Okay, so now I can simplify, so I've got negative 4 plus 4 times the square root of 17 and negative 4 minus 4 times the square root of 17. So here I only care about the positive one because I cannot have a length that's negative. So if I come up with a positive and a negative value, I know I only need to use one of them. So my x is approximately negative 4 plus 4 times the square root of 17, which is approximately 12.49. So I know that that length, that piece that we were missing, is approximately 12.49. So now here we're going to look at an aquarium tank. So here I'm asked to find the radius of this aquarium tank. Okay, but I see here that I have a secant that goes through my circle and I have a tangent. So I can follow the same thing. So I know I'm going to have my tangent squared, and then I'm going to use my secant, the outside piece, times the whole thing. Okay, so I take my tangent squared equals the outside piece times the whole thing. So here I have 2 r's and then times plus 8. So now I can simplify my numbers, and then I subtract 64 from both sides because I'm working to get r by itself, and then I'm going to divide each side by 16. So r, which is the radius of my circle, is 21 feet. So now here are a few for you to try. See if you can remember which piece you square and which piece and what else you multiply in here. So looking back at our learning target for today, we used segments of chords, tangents, and secants, and we looked at the different ways that we can use them to help us find some missing information. So now that we've done this, I want you to work on your homework for 10.6.